All right. So this is in the yesterday's session. Better I'll wait for five minutes. See, most of the students are joining now. All right. In the yesterday's sessions, we discussed about uh, the uh, the graphical extension of the MATLAB software, that is Simulink, right? So in this training, so we are going to cover the three major modules inside Simulink. One is the Simulink major library elements, then the physical system modeling using the Simscape. Under that, we also going to learn about the specialized technology library toolboxes, especially to design the power converters. So, and even I given the basic idea about what are the types of elements or types of blocks available in a Simulink. So there are three fundamental blocks. So one block we can call it the source type of blocks, and the second one is the sink type of blocks. Either we can simply call this one as a source is equivalent to an input type of blocks, and even uh, we can take one more the sinks as a outputs, where we are going to see the outputs. Okay, and meanwhile the rest of the other blocks which are included in the Simulink library we can call as the process library blocks or a process blocks, which will do some process, which may be an additional process or logical process, or the signal division process or signal calculation comparison process. Okay, it may be anything, and even it do some differentiation integration. Okay, even you can have a trigonometric equations, the square root functions. Okay, there are multiple other options. Okay, so that we need to explore each and every library element inside the Simulink main library. All right, so this is about the yesterday's session, and even I also given the what is the meaning of this step size, how this the models will work. See, every model is nothing but a simply at the front end. Okay, whatever appear the sine wave which is appears at the front end, uh, by default it is a built-in with the MATLAB software itself. So it will consider to be a matrix, and it will work on the principle of the signal flow from one direction, and this signal flow is a unidirectional. You may notice here, if I just click on this particular line, it will show from this point where the signal is flowing. Similarly, if I click on this only this line, which means it is a unidirectional flow from this point. Okay, so this is how a Simulink works. All right, so at the end of the yesterday's session I got one beautiful question from one student. Okay, so why should we learn MATLAB, or why should we learn, what is the need of learning this Simulink? Okay, so even I given the answer for that, but especially I think Tanzia Bano, she asked the question, right? So with the same question, I am going to give the brief idea and overview about the Simulink. What is the advancement of Simulink? So what is the uses of this Simulink modeling, and which are the companies which are adapted this MATLAB Simulink for their production purpose? Okay, so before to that we need to just explore the website, that is MathWorks. Go to Google. I'm searching for the website that is MathWorks. All of you, please do explore this website. The MathWorks is the origin of this MATLAB software. Okay, mathworks.com. Just click on this, the first website. If you open this website, ultimately we'll see the one beautiful image that is this related to an electric vehicle or as an automotive. See this, by the very first image you can notice that what is the use of this Simulink and MATLAB. See, so the MATLAB has the three major like products. Let's look into the what are the products which are available from this MathWorks. The first product is the MATLAB product. So in this MATLAB product, it is having a multiple like applications related to purely into the scripting. Especially you can work on the domain like AI, data science, statistics, math optimization, reporting, database verification, code generation. Okay, parallel computing. These are the purely the scripting related uh, items which are available from the MATLAB. The next product is about the Simulink. Okay, and this Simulink has a the different the varieties of library elements. So which are maybe the physical modeling, especially the Simscape, Simscape batteries, Simscape driveline, Simscape electrical fluid multibody. Okay, similarly for code generation, AutoSAR, block sets, real-time simulation and testing, system engineering, application development, verification and validation. Okay, so there are multiple applications. Okay, this is only the simple line. Like if you go inside this Simscape, it is a vast. Okay, so uh, you just need to explore this website first. Okay, and meanwhile, so along with this MATLAB and the second one is the Simulink, the third one is it is having a built-in applications also. Okay, there are beautiful application tools like signal processing tools, image processing and computer vision tools, control system tools, especially with respect to the control logic, fuzzy logic toolbox, predictive maintenance, robust control system identification like this. And even aerospace application, automotive application, radar. Okay, computational finance, computational biology, robotics and automation systems. Okay, teaching and learning. There are n number of applications which are built within the MATLAB. So these are the MATLAB tools. Okay, one is the three products. One is MATLAB is one product, Simulink is one more product, and the third one is the applications. There are for every domain there is a applications. Now let's moving on to the which are the companies or what are the service they are providing, which are the companies which are adapted MATLAB. Let's go into the solutions. Okay, if you consider the solutions, there are multiple applications using this MATLAB, Simulink and other application tools, especially in the field of AI, artificial intelligence, automated driving, computational biology, control system, electrification, predictive maintenance, mechatronics, Internet of Things, radar, embedded AI, embedded system, ERP systems, okay, test and measurement, signal processing, wireless, image processing. See, these are the applications. And now moving on to the which are the industries which are adapted MATLAB. So coming to the overview of the industries, aerospace and defense industry, medical devices, manufacturing industries, agricultural application, automotive, materials and mining, okay, quantitative finance and risk management, biotech and pharmaceutical, communication, railway systems, semiconductor industry, software and internet industry, energy production industry, industrial automation and machinery. See, almost all the industries which are adapted MATLAB and Simulink. Okay. Now, so being an electrical engineer and you're going to learn the Simulink tools with respect to electric vehicle application. So let's explore this, the automotive industry. In this automotive industry, there are multiple domains like automated driving, software defined vehicle, virtual vehicles, electric vehicles, and some standard vehicles. Okay. So being an electrical engineer and the topic is about EV, let's look into the electric vehicles. What are the possibilities through this MATLAB and Simulink? The see, the main thing is about the modeling of the system. Okay, so as the Simulink itself defines that it's the model based approach. Okay, you can model it, and this Simulink is designed for dynamically solved equations, or you can do the models for uh, uh, or you can build the systems, uh, and you can simulate the models in the dynamic manner, like as in the real time cases. Like you can run the simulation for infinite time, and even during the infinite time duration you can vary the parameters, the external parameters or maybe internal parameters. You can do what are the modifications you want, you can do. And even though with respect to instant changes from the input, so the system itself gives the resultant output for the dynamic systems. That is the one of the major advantage of this Simulink. And meanwhile, so in this by using this Simulink software, Simulink toolboxes, you can build the components. See, as in case of the embedded system, you are working with the components. Okay, you're not going to develop the components, you are just going to utilize the components. But here in case of the Simulink, you are going to build the components, or you can going to model the systems. Okay, that is the key difference. Okay, so in embedded system, you are going to write the program, you are going to assemble it, and you are going to test it. Okay, if you got any sort of the error, again you debug it and resolve it. Okay, that is a physical process. Whereas in case of Simulink, you can do the same thing in the virtual platform. Okay, you can do n number of iterations, and it will give the results instantaneously. That is the use of this Simulink, right? Then the major the models which are included in this electric vehicle, one is the main thing is the battery, the power electronics, the traction, especially with respect to the motor, engine, gearbox, and next thing is about the thermal system management. Even including all this, especially if you look into the power electronics, I am concentrating much on this, the power electronics part, and a part of the work on the battery, and also the part of the work on the motor part. Okay, so including all these things, there are the other application you can integrate it with. So even here we are going to build the vehicle modeling, you can integrate with the embedded system software, and even by adapting the AI driven modeling like AML and cloud based workflows, you can integrate everything to become a complete electric vehicle. But so it's a the like progressive learning process. So we need to learn the phase by phase. So in that the perspective, I am going to teach you about the foundations of the Simulink toolboxes, then Simscape, then physical system modeling, then into the power electronic devices. Okay, that is the flow which I adapted. Okay, and definitely that will give you a wonderful outcome for you guys. Okay, and similarly, even you can just look into the videos from of the most of the companies, especially General Motors is a company which is adapted this Simulink. Okay, and even BMW is adapted uh, Simulink. Airbus, the aerospace industry, Airbus, Scania. Okay, So these are the industries which are already adapted the MATLAB Simulink for their the model design purpose. Okay, even most of the pharmaceutical industries also adopted MATLAB Simulink. The management tools like the finance and business analytic toolboxes also available. More, some of the banks also adopted MATLAB Simulink. Okay, so in this perspective, so MATLAB having a varieties of applications. Okay, so you need to explore this through this website, that is mathworks.com. All right, so I hope I given the what are the users of the Simulink, what are the companies which are adapted, which are the companies which are adapting MATLAB. Just explore the website, go to the products, and even in the solutions, look at into the industries. If you look into the industries, especially the aerospace industry, you can just get the reviews, what are the feedback given by the each and every domain industries. Okay, like US Air Force, US Navy, it is adapted. Okay, Thales, Alnia, okay, BA systems. Okay, so even you can look into the feedback from the each and every company just by explore more customer stories. Okay, you can do that on your own. Okay, all right, so moving on to the today's topic, that is about the Simulink. So this is about the yesterday's class. Okay, we designed this part only, just connecting the two blocks. One is the sine wave block, one is the output scope block. We connected together, we got the output, and in between we modified the amplitude just by connecting a gain block, so that we are getting the both the outputs, like both input and the output. Okay, so if I simulate this, you're going to view both the inputs and the outputs. Okay, uh, similarly, now there are some basic things you need to understand, like here I given like the step size, and even here I am entering some the textual information. Okay, so what is this meaning? What is the meaning of this? How to represent the particular line with some information? How to recolor this? How to rearrange this? How to mark this area? Okay, so these are the foundation things we'll learn in this today's session. Okay, now moving on to the today's topics, go to the Simulink library browser. Okay, so the most of the students are using 2015A version of MATLAB. Okay, if you open the MATLAB software, click on the Simulink library icon, you will get the window, pop-up window like this. Okay, this is the window you are going to get, and here you need to click on this create new model, create a Simulink model. Click on this so that it will create a new model. Done. Now I'll just close this, the previous thing. Before to that, save this and close. All right, now see here, this is the library. From here we are going to drag and drop the components. Okay, so if I double click on any of these sub libraries, this is the Simulink main library. From here there are multiple sub library elements, okay, which is belong to only the Simulink. If I minimize this, then here I have a other domain specific libraries with respect to aerospace, with respect to AutoSAR. Okay, but we are going to concentrate on this Simulink. Now here you have a continuous dashboards, discontinuous discrete logic. Okay, we'll explore one by one. Okay, so all in one, including all these libraries, there are some commonly used blocks. Okay, most commonly used Simulink library blocks which are available under commonly used blocks. Just click on this commonly used block. So here each element which are available under this commonly used block are available under dedicated sub-library elements. So you can see here there is a bus creator and bus selector which is available under commonly used block, but its origin is from the signal routing. Okay, signal routing. And here is a constant, it is a source type of library. You have a gain which is comes from the maths library. Okay, a discrete time integrator which comes from the discontinuous. Okay, a ground, an integrator. Okay, each and every element have its own functions, own operations. Okay, it will do some particular work or it will do some process. Okay, so now, so let's explore the foundation library. That is, let's go with the sources. What are the varieties of signals which are available in this sources? Okay, just click on the sources. Here we are going to have the multiple sources. Here is a band limited, the white noise, the cribbed signal, the constant. Let's say one constant value. Okay, and a digital clock. Okay, spreadsheet, ground, workspace. Okay, a pulse generator, a repeating sequence. Okay, and you may notice every time if I drag and drop any component, see, I'll just drag and drop this component, the library will again disappear. Just by pressing the alt tab button, I can open the previous window. But if you want this entire library sheet should be stay on the top of this empty canvas, then you have an option, that is just by clicking the pin icon, that is stay on top. Please note this, stay on top. If I click on this, now if you drag and drop any component, it will stay over the top section. It won't disappear, right? Now, so in the source, I'll first start with a simple, again start with the same sine wave block. Okay, I just want to show you the what is the use of this step size and how best it will give the results. Okay, under sinks, I'm going to use the scope, and if you want to see the visual graphic, the textual output, you can connect the display also. And in the math operations, I'm going to use this again gain block. Okay, minimize this. Can rearrange this, and if you want this entire element, it should be fit into the main screen. Okay, it looks like very small, right? If you want to fit these items into the entire screen, then you just need to press the space button, just space bar, press the space bar, then it will auto fit into the screen. Or else there is a one more option called, here is the auto scale, auto fit. Click on this. auto fit into the screen. Now here it is, if you are doing any like drawing, or if you do any painting, you'll write some information about the diagram, right? Similarly, this is one particular model. I can consider from here onwards, we'll consider each and everything as a model. Okay, every work is a model. Okay, we need to give some information about the model. Okay, so that information, that is in the form of a text, we can call it as a annotation. Okay, just double click anywhere on the screen, just double click anywhere on the screen and type create annotation, model annotation. So model annotation, which means it, which will give the text information or textual information, text information about the model. Okay, even you can, in this annotation, even you can like resize this, you can move this annotation anywhere on the screen. Okay, it is not fixed, and this annotation won't affect your model performance, right? It's just like a comment in your program, right? Annotation won't affect the model performance, right? Please note this model annotation, which is gives the textual information about the model. Okay, so now in this model, I am going to give the annotation or the information as this is a simple amplitude modulation of a sine wave. I can give the name as amplitude modulation of a sine wave. Amplitude modulation of sine wave. Right. This is an information, and in this model, just you can double click, and if you want to increase the size of the font, you can do it. If you want to change the color, you can change the color also. Okay, and if you want to make it as bold, you can make this. This is the just information about the model. This we can call it as a model annotation. All right, now I am going to connect a sine wave and each and every element in a Simulink. Like here, this is one block, this is one more block. Okay, like this, every block is customizable. You can rename the blocks, even you can recolor it. Okay, so first, instead of a sine wave, I can just rename this, like simply sine underscore wave. This is my block name. Here I'll simply type gain block, or we can amplitude gain, amplitude gain. Okay, here instead of scope, you can output, you can rename as output. This also won't affect anything. So the process of renaming is, we can simply call it as a the block renaming. What is that? Block renaming. Okay, and in case of this Simulink, if you copy any of the block, by default Simulink itself changes the block name. Okay, let's say if I copy this output Okay, I'll just select this. There are multiple options to copy the blocks. As usual, you are aware of Control C and Control V. This is the first process. Select this, Control C and press Control V. It will appear, but you can notice here the first block name is output, and by default it will change the name to output 1. And if I again tries to change this as with the same name, it will give some error. It will disappear. See, it is giving an the error that the name output already existed in the untitled. Untitled means this is the file name where I haven't given any the file name for this. By default, the name is untitled. So in case of any model, you need to change the names. Okay, if you want, you can change the names. By default, it will changes the name to the series, the numerical series output 1. If I copy one more thing, it will by default it changes to output 3, output 4, like this. Okay, the easiest method to copy is just select, click the right mouse button and drag it, automatically it will copy. Or else just select, hold the control key and drag the mouse button, it will copy. Okay, so I'll just give the annotation here, copying the blocks. Option 1, Control C and Control V, that is a one process. The next thing is select the block, hold the right mouse button and drag. Next, one more is select the block, hold the control key and drag the left mouse button. So these are the options to copying the blocks. If you want, you can notice this, note down copying, how you can copy these blocks. All right. So now if you want to exactly zoom this particular area, then you can have here is a option, zoom area. You can select this area and it only this part will be fit into your screen. And if you zoom out, you will get all the annotation part also. Okay. All right. Now you renamed the blocks. Okay. Now I'm going to connect the signal, and this is my exactly input, and I want to connect one more block here. So I'm using 22 version, so directly you'll get an option to create a one more the input port from the scope block. But most of the students, you are using the 2015A version. In that case, if you want to have one more input here, like if you want to add one more input for this, especially for this output for the scope block, just double click, go to the configuration properties, and here the number of input ports is by default is 1, and you can make it as 2. Apply OK. Now you can see it is increased to 2. And if you want to connect this signal from here, the reverse is very easy. Connecting the signal from the reverse is easy, but if you want to connect from here only, this is like bit difficult. You can't able to connect this. Okay, but there is a one shortcut. Just if you want to connect from this point, now from here you need to hold the control key, then you are able to connect it. Here it appears a one simple node. Okay, this is a junction. Okay, where the signal is splits into two direction, right? Now in this output I want to assign which signal is what. Okay, so whether this is an input signal or an output signal, we need to declare it. Okay, to declare the signals, here one more option is called signal labeling. Okay, what is this? Signal labeling. What is this signal labeling? Signal labeling is nothing but it is also a textual input about the signal, and this information is connected within the signal line. Okay, it is not like an annotation. See, in the annotation you can move anywhere, but if you go for the signal labeling, it must be connected to that particular signal line. Okay, in order to give this signal labeling, just select the line, immediately double click, and now you can give the text information, that is input signal. Simply you can type input or input signal, done, and this signal immediately double click and make it as output signal, right? Now you can see here this signal is not moving away from this line. Wherever the line is connected, always it is connected to that particular signal line. If you want, you can just move through the same signal line. Okay, see, up to here is an input signal, right? Here is the output signal. So now for the amplitude gain, I'm changing the value of to 5. Now if you go for the simulation, it will give the results. I'll run this simulation for 10 seconds by default value. See, on this top layer, it will appear like input signal and output signal, right? But if you want to differentiate with the two axes, like one top axis is about input and the bottom axis should be about the output, in that case, here is an option. Again, you need to go for the configuration properties under scope block. Click on this. Here is an option for the layout. Click on this layout. You can select two layouts. Okay. If you want side by side, you can opt for this. Apply. Now you can see the inputs. This is the input and this is the output. If you want one above the other, then you can again go for the layout option like this. This is the input signal and this is the output signal. So in the upcoming sessions, like you are going to deal with multiple varieties of signals, like especially in case of three-phase AC networks. So you need to consider R phase, Y phase, B phase, along with the constant other related uh, signals you need to deal with. In that case, so the identification or signal labeling plays a major role. Okay, so that's why this the important task. This is about the signal labeling. Okay, all right. So now moving on to the one more thing. If you want to see some textual or digital output, you can connect here, connect to anything. Either you can connect to the input or the output. Just simulate this. Now you can see here it is displaying only the terminating value. At what time the signal is terminated? See here, in this particular area the signal is terminated. The final value will be displayed on the output side. Approximately see 0.55. The same value will be appeared on the output side, 0.544, right? Next thing, signal labeling is done, copying of the blocks is done, block renaming is done, model annotation is done. Now creating an area, I'll just disconnect this. Let's say there are multiple blocks like this, and even each like models have a different applications or different like uh, amplitude gains. Let's say I'm changing this to 20. Okay, if I simulate this from each scope, it is connected. You'll getting the different outputs. Okay, but I want to connect all the signals into only one output block. Okay, in that case, can just take one more the scope block to see only the output. I'll connect like this is the input, this is the first output, then from here this is the second output, from here is the third output, and I need to differentiate each with some area. I need to identify for easier identification. I will create a particular area over it. Okay, this is also won't affect your system performance. Okay, so in order to create an area, just click on the mouse button, drag this area, select up to which part you need to cover. So release the mouse button, and immediately you will get an option like create the subsystem, create an area. Okay, log. Just by selecting this the square shape, create area, it will created with some, it will appear like a just a separate section. Okay, similarly here also create area, create, and for each area you can even give the information, like if I click on this area, so you can see here there is a question mark here, so here you can give the information like amplitude 5, next for this amplitude is 10, for this amplitude is 20. So it is also just like an annotation, it is just giving the information about the area, which area, what is the main reason for this creating area. So this area represents an amplitude modification of 10, this area represents an amplitude modification of 20. So similarly, like in the upcoming classes, you are going to differentiate the some power electronic components, power electronic converters into different area, and then you need to connect it to one major block. Okay, that is the use of it. Will just combine the groups and it will appears in one particular section. Okay, that is one part of the creating an area. Okay, so this is about creating the area. Okay, so now, so there is a one more concept, that is the grouping or creating the subsystems on model annotation. Okay, so that I'll do the coming upcoming model. Okay, before do that I'll just save this model, save. Yeah, so this class about the Simulink basics, Simulink basics. Oh, I'm getting one error. Intentionally, I did one mistake. Okay, just want to explain you about the concept. See, just look into the error. The Simulink Basics is not a valid model name because it is not a valid MATLAB function name. Okay, the Simulink having its own structure to define the names. Okay, it should not consist of any spaces. Instead of space, you can use the underscore, and I'll just give the write up about the naming, saving the file name. So file name, file name should not contain space or special characters. Okay. Next thing is the should not file name should not start with numbers. Okay, let's say I'll give the example like one model or you can simply type as a fifth example. So this is an invalid name. Okay, these are the invalid. Okay, and even you have a limit to save the models. Okay, you can up to use the 56 characters to save the variables. Okay, and sorry, I'll just look into that particular the count, how much way the characters you can save for this file name. As of now, so you don't use the space, and you should not start with the numerics. Okay, so this is a file saving the instruction. So now moving on to the next concept, that is creating the subsystem and creating mask over the subsystem. Before to that, so let's say I want to change the variables, like instead of assigning the value from this MATLAB, just double clicking on here. Let's say instead of the value 5, I'll give the as a variable name, like let's say the name as am a, the name is a amplitude a. Apply, it will show some error, not a problem. Again here also I'll change the name as b for the second one, and here I'll save this, give the variable name as c. Okay, now you can notice here, if I try to simulate this model, if I try to run this model, definitely I'm getting the error because these are not declared. You can just look into the error, the invalid setting in Simulink basics amplitude gain for the parameter gain caused by the variable b does not exist. Similarly, caused by the c does not exist, caused by a does not exist. Okay, which means you are not defined anything for this. MATLAB won't understand what is a, what is b, what is c. But you can assign the value to a and b externally, not from the Simulink, even from the MATLAB also you can give the names. Okay, so here I'm going to the MATLAB software. In the command window, I'll give the value of a is equal to 10. Now you can notice here the value a is assigned in the workspace, b is equal to 20, it is also assigned, c is equal to 35, it is also assigned. You can look into the workspace. I'll just given the values from this MATLAB command window, and now again I'm moving to the main file, that is the model file. If I run this model, now you are getting the results. Here the value which I have given is 20. Let me check what is the output I am expecting. Now I can notice here one is 10, one is 20, and one more is 35. We are getting the different answers just by giving the inputs from the MATLAB window. So MATLAB and Simulink, these are not a different softwares. This is our interconnected softwares. Even you can run, or whatever the method which is solved in the MATLAB, the same procedure is solved by the Simulink. But at the front end, it looks like a model. At the back end, it solves through a matrix. Okay, that is the main conclusion I just want to give. Okay, this MATLAB and Simulink, these are not too different. Okay, these are interconnected. Whatever the model which is appearing at the front end, okay, ನೀವು ಇಲ್ಲಿ ಏನ್ ನೋಡ್ತಾ ಇದ್ದೀರಿ, ವಿಜುವಲಿ ಏನ್ ಕಾಣ್ತಾ ಇದೆ, okay, so ಇದು ನಿಮಗೆ ನೋಡ್ಲಿಕ್ಕೆ ಮಾತ್ರ ಇರುವಂಥದ್ದು. Okay, it's just like a model you are placing and you are connecting, but this signal flow, which in turn works as a matrix, which will solve the matrices and giving the results. And whatever the graphical output, this is also in matrix output. Okay, this is how the MATLAB solves everything in the form of a matrices. Okay, so this is about the today's session, and the one more topic I left with, so I'm going to cover that topic now. So moving on to the next topic is about the grouping of the elements. Okay, so instead of the creating uh, the blocks, or instead of creating uh, the areas, we can go for the grouping of the elements. Okay, let's say uh, this is one particular group. I'll just remove this area. If you want, you can just delete this area, select and delete. Only area will be deleted. Okay, let's say I want to combine these two blocks into a single block. Okay, these are the, in this totally 1 2 3 4 blocks are there. I am selecting these 4 blocks, and I want to combine these 4 blocks into a single block just by pressing the shortcut key Control G. Control G. This is called the subsystem. Now we can notice here it is renamed as a subsystem. I'll just undo this. Select this area. Okay, you can use the shortcut key as Control G, or the very first option is create subsystem. Just click on this create subsystem. What does this subsystem means? This subsystem is nothing but grouping of multiple blocks into a single block. Note down, subsystem, grouping of multiple blocks into a single block. So this is, you can call it as a subsystem. The shortcut key is Control plus G. This is the shortcut key to group the elements. Okay. Now, if I see here, even you can resize this group. Just double click on this group. Again, it will go inside the subsystem, so that whatever the model is connected, it appears the same. And you can notice here, in the previous case, it is connected to a particular especially to the scope block, but after grouping it is connected with the by default uh, the block, that is out block. Just double click on this, say this is a output block. Even similar to this, you can also connect the input blocks. Okay, inputs and output blocks. So this output blocks will provide an output port for the subsystem or a model. Okay, the output when disable or initial output parameters only apply to the conditionally executed subsystem. Means, see, even externally also you can connect this type of output blocks. Okay, and these output blocks are by named as output only. but as I already given the signal labeling is ultimately assigned to the output output ports. Okay, so this is how we can combine the multiple blocks into a single block. Then what is the use of this combining multiple blocks? Okay, so for this I just want to give the example. In the previous class, I displayed one the image regarding, yeah, so this is a hierarchical level of image. Okay, here the energy management unit, it is representing as a one block, which means it is a one subsystem. Inside this there are multiple other blocks. Okay, a battery pack is simply appear as a one subsystem, but inside this battery pack there are multiple cells which are connected in series and parallel combination, and there is a one battery management or the sensor unit it is connected. Okay, there is a one thermal unit, okay, one thermal cooling unit which is also connected, and combining all those elements, it will look at the end, it look like a one subsystem or a battery pack. Similar to this as three-phase AC motor, here also in the three-phase AC motor part there is a one cooling unit, there is a gearbox system, there is a the other mechanisms which are connected having a multiple blocks and grouped together to form one three-phase AC motor block. Three-phase PWM inverter. Here also the multiple inverter, like multi-level inverter combination, some switching elements, some power electronic devices which are integrated to form into a single block. Okay, that is how we can combine the multiple elements or a multiple, we are grouping the multiple blocks into a single block, we can call it as a subsystem. And this subsystem may be dependent or it may be independent or it may be a triggered subsystem. The system works from the different trigger signals. Okay, this will explore in the upcoming classes. Okay, and there is a one more option like after this there is a one option like this layer, like if you just want to, if you double click on this subsystem, instead of going inside the block, you can create a dialog box over the subsystem like this. What is this dialog box? If I click on this sine wave block, a pop-up dialog box will be appear. This is a parameter dialog box. Okay, which will give the information about the block. It is having a option to edit, like you can having option to customize the parameters. Okay, you can enter it, and if you press OK, then it will run. Similar to this, there is a one more option. You can create a layer over the subsystem, that is also possible, that we can call it as a masking over the subsystem. That we'll discuss in the next class. Okay, so at the end, so in this today's session we discussed about the foundations, about uh, just a minute. All right, so here we discussed these are the topics. One is creating the model annotation, which will give the information about the block. Next, block renaming, we can just rename the blocks into different varieties. And to copy any blocks there are multiple options, like that is control C, control V, that is the first option. Hold the right key mouse button and drag, that is the second option. And hold the control key and drag with the left mouse cursor button, so that is the one more option. The next thing is about the signal labeling. You can give the proper naming for individual signals. It may be any sort of the signal. You can just declare whether it is an input signal or an output signal or any or modified signal. You can declare it just by through signal labeling. Similar to that, next one is the creating area to identify any sort of the blocks or any the models into different segments. You can either create the area, that is one option. So it is appear on the top layer of the model, and there is a one more option, creating the subsystem. If you want to combine or group the multiple blocks into a single block, then we can call it as a subsystem, and you can save all these file into from some standard format, that is you do not use any the numericals in the beginning of the file naming. Do not use any special characters or the spaces. Instead, you can use the underscores. Okay, so this is about the overview about the today's session. Okay, if you have any sort of the doubts, please do ask the questions. Any doubts? Any doubts? Darshini, Gausia, Prakash, Uma, Sandeep, Sangeeta, Shahid Khan, Shoaib. Guys, are you there in the class?
Yes, sir.